In the compiler design, we're going to discuss the subject code is 21 CS 601. Myself, Sharmila, Assistant Professor, Department of Computer Science Engineering in the R.M.D.E. Engineering College. We're going to discuss about that what are the compiler architecture. In that compiler architecture, already we have discussed in the last few videos what is lexical analyzer, what is syntax analyzer, what is the semantic analyzer, that is intermediate generator, code generator, in that code optimizer, code generator, what is symbol table, how the intermediate code is converted from the source program language to a target program language. That is the architecture of a compiler. In that intermediate code, that is the intermediate representation language that tries the front end and back end together. That language and machine neutral depends upon how being it is processed, and one intermediate language will be used by a compiler. More than one intermediate language can be used by a compiler. That is not a problem here in the intermediate code generation. In the intermediate language level, how that high, medium, low, that representation is done is a given one example, small example, how that is done here. In that intermediate language code has a graphical IRF, that is abstract syntax tree, that is DAGs, control flow graph, linear IR, that is linear IR. We have a postfix and quadruples. That is the form of 3 address code generation in the form of postfix and quadruples. Quad means 4 values, the attributes will be there. In that, the graphical IRs, abstract syntax tree, that is retain essential structure of the parse tree, eliminating unneeded nodes. DAG is nothing but directed acyclic graph. It avoids duplication, smaller footprint, as well as it compact to execute the flow. Control flow graph, that is CFG, is explicitly model control flow, how the controllers flow inside a program. So here they are given what is that AST, that is abstract syntax tree, and what is directed acyclic graph. For a given example, A equal to B into C minus, that is unary operator minus C, plus B into unary operator minus C. How that abstract syntax tree is drawn as A, that is first value identifier A equal to, that is plus operator, this plus operator. One part is B unary minus into unary minus C. Another part is B unary minus C. But here in the DAG, we can use this mentioning that arrow to represent the two similar things into a one addition symbol operator, that is direct acyclic graph, how the direction is followed. And then linearized IC, in that stack based one address compact, 3 address code is quadruple, up to 3 operands and 1 operator is used. Example given for the stack is push pop, multiply that push and pop that X value, multiplying the values using the subtract. Like that, we will do some operation using the stack operation, push and pop. And 3 address code, we are using a quadruple. Quad means 4. That is 3 operands and 1 operator. We are using to write a 3 address code. They have given example for A, B into unary minus C, B into unary minus C, how that particular value is drawn for this DAG. So they have given example how to draw this. Assign A plus B, B minus C, B minus C. They are assigning a temporary variable T1 for this plus value. And then for T0, T1, we are giving into T1, T0, T1, T0, and finally T1 we are storing. The T1 is assigned to this variable A. So this is a DAG representation, how the temporary variable is assigned with the 2 cyclic wave only. We are using T0 and T1 variable and storing the value. Generating intermediate code, just type checking, we need to use the syntax of the input generator, that output, declaration, expression, control flow, procedure call, return. So processing, declaration, global variable versus local variable, binding name, storing the location, integer, boolean, like that basic data types, composite types like records, arrays, expression, code generation. They are generating a code, how to generate that. Issues in processing expression is correct code, whether we are generating, whether the type checking conversion is correct, whether the address is calculated, the constructive type, expression in the control structure. They have given a small expression for that. They have drawn how that value is composed, how the expression is evaluated. So here what we have discussed is about how to draw a DAG, how to draw a abstract type tree, and what are the different types of declaration, what is the compiler architecture. In that, what's the intermediate code, what is high, what is medium, what is low, what is the graphical IR, what is the linear IR. In the graphical IR, again, it's split into two, AST, DAG, and CFG. AST is abstract syntax tree, DAG is a directed acyclic graph, and control flow is a CFG. We have seen the two example, what is the AST and what is DAG. I hope you understand how to draw a DAG. It will be asked frequently in the 2-mark question. Again, we have learned what is 3-address code, how to write a 3-address code in the form of quadruple. That quad is for 4, in the 3 for operands, and 1 is for operator. So I hope you understand how to draw a